Hello, this is Thomas Van Bommel recording for PROG2200 M01 Collections. Uh, Today we wrote 3 small programs to coincide with these 3 requirements of the assignment. As you can see, the first one, sorted set, write a Java program to sort a Java array of 10 names without writing a sort routine. Use sorted set, print the results. Alright, we'll just hide this guy, and as you can see here, I've created a file, sortnames.java. At the top here, we have 10 names in a final string array. Obviously not sorted, they're just randomly in there. In our main function, we then print out the unsorted names, just as a string. And then we print out the sorted names, which calls the function down here, called sortNames, which takes in the parameter of the array of names, puts them into a tree set, which is stored in a sorted set and then returned, which is then printed out as a string. And if we run that, we can see the results. We have unsorted names at the top and sorted names at the bottom, without any loops, which is kind of nice. Alrighty, the next one, hash map. Write a Java program to store the car model, year, color, price of its cars on a used car lot. Print the results. And here I've got a car dealer script, which for this script, you can see here on the left, I created 2 files, a car dealer, which is our main function and also serves as a car dealer object, and then a car, which is this down here. And our car is defined, has a model, color, year, and price. Nothing too fancy here. I overwrote the toString method just to make it look a little bit better, especially with decimal formatting. The output of currency looks a lot better. However, looking at this, I don't know if that's correct, but I'll ignore it for now. So there's our car model. And as you can see here, the car dealer stores a hash map, which takes a key of an integer, that's this ID down here, and a value of a car. And so when you create the car dealer, it just instantiates this used cars hash map, and then it has a function add used cars, so you are able to add used cars to this car dealer's inventory. And as you can see, it also returns true if it was successfully added, false otherwise. And then a function to print the stock, which just simply loops through each of the used cars and prints out its value in a new line character. And then right here we have our main function, which just creates a car dealer called dealer, and then adds 10 cars. Yeah, adds 10 cars, which I randomly selected from the internet. These prices are not correct, but... And then just prints the stock. And if we run that guy, you can see here, it just prints car after car in alphabetical order as well. Oh, never mind, I added them in alphabetical order. Alright, so the next one. Hash map, write a Java program to store the shape, size, color, and position of a graphic object in a hash map. Use an an enumeration for the shape and color. Make a collection of these graphic objects randomly populated, and then print the string version toString of the objects. That is, randomly generate shape, size, color, and position and populate your collection. And over here in the collections.hashmap, we have our main function and a graphic. Our main function is right here. Just get rid of all this stuff here. And there we are. So this is our main function. It has a hash map which again stores an integer and a graphic. Again, the ID is the same thing for the integer as the car dealership. And then in here it just adds a random graphic of 10, which we haven't looked at graphics yet, so let's do that. So here's a graphic. It contains a public enumeration called shape, which contains everything from a one-sided to a 10-sided shape. And then another public enumeration color, which I'm pretty sure I have a color for every letter of the alphabet. I don't know if all of them are actually colors though. Like Queen. Queen's not a color, I don't think. But anyway. We then have the actual graphic itself stores its shape, its color, its size, a position X and a position Y. When you instantiate it, you can pass in all these parameters, and it will set those accordingly. Or you can call this function called random graphic, which will create a random double and then multiplies it by a large number. And then, excuse me. And then here, so we have an array of shape, which simply takes the values inside this shape object, takes all of them, and puts them into an array. The same thing with color, and it returns a new graphic shape with a random shape out of this array using this random double. And I only did this to make it fancy and not have to call math.random a bunch of times. I don't know if this is actually truly random because I'm technically using the same number for everything here, but you know, it gives the illusion of random, so good enough. And then below that is just a toString method to print it out to the console. If we go back to our main function here, you can see that we add 10 random graphics to our hash map called graphics. And then for each of those graphics, we're going to print out its toString method. And our add random graphic here simply increments the ID and adds a graphic.random graphic, as you can see there. So if we run this guy, it's similar to the car dealership. We get a much similar output with the name and then all the attributes here. As you can see, we got random, as random could be the size of values. As you can see back in graphic, size will only generate up to 50, 0 to 50 using the modulo. X and Y will only go from 0 to 1,000. If you wanted to change that, you could change that, but again, it's written up here as well. So that's why those numbers are the way they are. And again, selects a random color, selects a random size, random position for each object, and fills it with 10 objects. Alright, so that's been Collections for Thomas Van Bommel, class PROG 2002. Thanks for watching.